Hi there, this is section 6.4. We're on page 380. I hope you've had a nice Christmas break. I'm assuming most of you are probably watching this. It's probably New Year's Day, later in the day, and you've waited till now to watch this. Some of you, if you were really motivated, you did it the weekend before Christmas. But I'm assuming if you're anything like I was at your age, you probably waited until it's New Year's Day right now, later on, and you're having to watch this video. We're solving compound inequalities today, and we're kind of getting close to a chapter quiz, which will happen, middle and end of this week. So let's talk about what a compound inequality is. First of all, a compound inequality, it's like combining two inequalities together. It's a compound inequality. It's two separate inequalities that are joined. All right, we're combining them together. Now, there's two ways we can combine them together, and there's words that indicate how we're combining them together. The word "and" means the intersection of the inequalities. Remember, an intersection is what they only have in common. So I know some of you didn't like this early in the year. Remember, earlier in the year, we were working with Venn diagrams. And I know that was a sore spot for some of us. The Venn diagram wasn't quite what we wanted to do. But remember, when you have a Venn diagram, what they have in common "and" would mean the following. It would mean where they are in common, in here. This is where circle A intersects circle B. It's only where they're in common. That's what "and" refers to. It's an intersection of the inequalities. Where the term "or" refers to a union of the inequalities. Let me try to move this out of the way if I can. There we go. Okay, oops. Got some scribbling here. A union of the inequalities is "or." Okay? And what that means, let me get these out of here. Boy. There we go. Get that out of the way. Just wanted to get those out of there. Okay. Or stands for a union. That means what they have completely, not in common, but what they completely, I guess I could say, combine together. Probably be the best. Remember my baseball card example earlier in the year? If I took my Detroit Tiger set of cards and united them with the Lion set of cards, it'd be all the Lion and Detroit Tiger cards thrown together. So a union would be this. It'd be taking all of A and all of B and combining it together. That's what an "or" is. So "and" is what they only have in common. Maybe I'll shade that again in the blue in here. Here's an "and." It's only what they have in common. Where an "or" is just combining everything together. So that's how we can combine inequalities together, either by "and" or "or." "And" is only what they have in common. "Or" is just combining it all together. Okay. Now, I think probably the easiest thing to do is just to have us actually graph some of these, and then we'll actually solve some of these and graph them. Okay. So let's do that. So if I go to question 3 of the bookwork, and question 3, by the way, we're on page 384 right now. Question 3 is to translate this phrase into an inequality, then graph it. All real numbers that are less than 6 and greater than -2. Maybe I should say one more thing as I'm just thinking here. When you have the word and can be written as a compound inequality. And a compound inequality, what I mean by that is it's a triple inequality, like in this form. So I'm just going to make up a number. Some number is less than equal x less than 8. That's a compound inequality. I have like a triple inequality. I can write triple inequalities when they're "and" statements. So that gets me here to question 2. It says all real numbers that are less than 6. So I want values for x that are less than 6. And they're greater than 2. So in other words, alligator would be eating x for anything greater than equal 2. Okay? I just translated that verbal phrase into an inequality. Now I want to graph it. So to graph it, remember, I'm going to have two key points. I have a key point at 2 and a key point at 6. So let's do that. My key point at 2, I'm actually going to color in because I can equal 2. But remember, my other key point at 6, I'm keeping an open circle because remember, we can't actually equal 6, but we can equal 2. And everything in between needs to be shaded. So I could just do this. There is a solution set for that compound inequality. All right. Let's do one more like that. Let's do number 4. Number 4, all real numbers that are less than or equal to negative 8. So I want x values that are less than and equal, or equal, I should say, to negative 8. Or, now or means that these cannot overlap necessarily. They're not, or I shouldn't say they can't, but I'm looking to combine everything together. Or is to combine it all together. It's not like and where it's only overlapping. Any values for x less than 8, negative 8, or, that's the key word, or greater than, not equal, greater than 12. Well, let me graph this now. Negative 8 greater than 12. So I have two key points. One key point is at negative 8, and the other key point's at 12. Let me just add that on here. Here's 12 here. Okay, I got open circles. Let me go back and double check. We can equal negative 8, so I'm going to color that in. What I'm going to do is combine together, or means that any values less than negative 8 will work, but any values greater than 12 will work. My graph would look like this. Okay, or I'm combining these together. Obviously, there's no values that can be greater than 12 and less than negative 8 at the same time. Okay, this is going to sound really bad if there's any parents watching. I hope you forgive me here. I think the best way to understand the words and or when it comes to this is by thinking of a bet. And I know I'm not trying to make anybody a gambler, but I'm just saying, if you think about a bet, think about the Lions played Arizona this weekend, and the final score, you might remember, it was ugly. Arizona won 38, Lions 10. Okay? So let's just say that I walked up to you before this game happened, and I said to you, I bet you $10 that the Lions are going to lose, and there's going to be more than 40 points scored in the game. Lions will lose, and more than 40 points will be scored. Okay? And means they both have to happen. So, in this case, if I bet you that the Lions would lose, and there'd be more than 40 points total, I would have won our $10 wager because they both happened. Okay? That's a little different than saying or. If I said I bet you the Lions would lose, or there's more than 40 points, if either one of those things happened, I would win. For example, let's just pretend that the final happened to be 28 to 10. The and bet I would have lost because remember I said Lions lose, and I said more than 40 points, more than 40 points. Well, if this happened, I lost the bet. Both these things didn't happen. There was only 38 points. Or is different. If one of these two things happen, then I would win. Well, it's the same kind of idea with this. Or means, think about it. If you have a card game, can you draw a card greater than 12 and less than negative 8 on the same draw? And obviously, no. I mean, there's no card greater than 12 that also is the same as numbers less than negative 8. So if you have to draw one of those cards at the same time, you've already lost. You can't have them both happen. Or if I said, okay, to win this game, we have a special deck of cards, there's positives, negatives. If I said if your next card is greater than 12 or less than negative 8, you win, that could happen. If either one of those two things happens, you win. Okay, so I think that might be an easier way to explain what the difference between and or is. So I did two graphs. I did an and scenario, and I did an OR scenario. Let me just make up one more. Let's say they wanted me to graph. I'm going to do the same problem twice, but one with an and one with the OR. Let's say they wanted me to graph x greater than equals 0 and x less than 5. Okay, if they wanted me to graph that, I'll graph it here. Here's my key point, 0. Here's my key point, 5. I only want the values that do both. Well, that would be here. But now let me do an OR. Let me change the problem and say it was x greater than equals 0 or x less than 5. That means I'm combining everything together. Well, if that was the case, I guess I would start here and I would do this. Well, let's think about it. That would be all the values here plus all the values here. In other words, it's just anything. So the word OR versus AND tells me two different things. AND means it's only what do they have in common. The only values where x is greater than equals 0 and less than 5 are right here. But when I say OR, it could be any value greater than 0 or less than 5 works. Well, let's think about it. Let's pick negative 100. Is negative 100 greater than 0 or less than 5? Well, yeah, it's less than 5. It's OR. Or let's pick 1,000,000. Is 1,000,000 greater than 0 or less than 5? Well, yeah, it's greater than 0. So the word OR opens up a whole bunch of different possibilities. Okay? All right. Let's talk about solving compound inequalities. That's the second major thing they're going to have you do. And if you look on questions like numbers 9 to 20, they're going to have you solve compound inequalities. Okay? So I'm going to do a couple of those and we'll graph them. Okay, so let's say we had number 9, and it's 6 less than x plus 5 less than equal 11. Okay, now this is an AND problem. It's a compound inequality. So I can think about this as x plus 5 is greater than 6, right? We're alligator eating x plus 5, and I have x plus 5 less than equal 11. All I have to do to solve this is just solve each of these for x. I could take away 5, which gives me x greater than 1, and I have take away 5 here, and I would get x less than equal 6. I need to graph this. Now, sometimes people do a shortcut. I'm going to show it to you both ways. I used and I broke this into two inequalities. There's one other way you can do it. I'll do it in blue here. I could have kept this as a triple inequality. I want to take away 5 here. I got to take away 5 from every. Imagine a science scale that had 3 plates, not 2. You know, I've always told you an equation is like having 2 plates, right? If you do one thing to one plate, you got to do the same to the other. When you have a compound inequality, it's like having 3 plates. As long as you do the same thing to all 3 plates, the compound inequality will stay true. Well, if I take away 5 here, I get 1. Oops, I want to do that. If I take away 5 here, I get x. And if I take away 5 here, I get 6. Do you see how I'm getting the same thing? X greater than 1 and x less than equals 6. All I got to do is graph that now. So I had a key point at 1. I had a key point at, I shaded in 1. I didn't want to. Key point, open circle 1, close circle 6. And I wanted everything in between. Okay, I just solved that that compound inequality. If it's an OR problem like number, let's say 15, if it's an OR problem, we do the same thing. It's just that it's not written in one inequality. We just have separate inequalities. So I have 2r plus 3 less than 7, or, remember, OR means we're combining everything together, or opposite r plus 9 is less than equal 2. Well, I got to solve this. Well, I can take away 3 from each side here, and I get 2r less than 4, and I can divide by 2, and I get r less than 2. Or, over here, remember, take away 9 from each side, I get negative 1r less than equal negative 7. I divide each side by negative 1, And I'm going to put a star next to this. Remember, when you divide or multiply each side of an inequality by a negative, you must switch that inequality symbol around r greater than or equal to 7. Well, let me graph that. I want to graph all values for r less than 2 or greater than equal 7. So I'm going to do that right here. So I said I had less than 2, greater than equal 7. So here's 2, open circle. Here's 7, shaded in. I want all values less than 2, but I also wanted all values greater than 7. Okay? So maybe I'll do one more just to make sure. I think we have this down. I don't want to make this video too long. Let's go over here, get one more new sheet. We'll do one more. Let's say I had a question. Let's go to 23. They want me to write a verbal sentence as an inequality, then solve the inequality and graph it. So here they're going to have me write it out, solve it, graph it. It says 5 more than x, that means I'm adding 5 to x, is less than 8, or 3 less than x. Okay, that means I'm taking 3 away from this. Remember, 3 less than x, 3 less than 10 would be 10 minus 3, so x minus 3 is greater than 5. Okay, I want to solve this. So I got to take away 5 here and here. I'm getting x less than 3. Or if I add 3 here to each side to solve this inequality, x greater than 8, I got to graph that. So I have open circle 3, open circle 8. Let's do that. Open circle 3, open circle 8. And I wanted, I believe, the values less than 3, greater than 8. So let's graph that. Here are the values less than 3, and here are the values greater than 8. So I just graphed that. Okay. I think that's enough to get us going for when we come in to class tomorrow on Wednesday, and we can go over more questions if you have questions in class tomorrow. All right. See you tomorrow.